Okay, ladies and gents, grade 11 and 12. Let's see how we can collect the 7 mark on this question. I need you to consult your exam guideline on how to define the term normal force. So now we have two blocks, as you can see on the diagram, and they are connected uh, with a rope T. So they say that both of these blocks are at rest. The slopes make an angle of 30 degrees with the horizontal, and friction on the slope cannot be ignored. The first 2.2, they want us to draw a free body diagram indicating all the forces on the 2 kg block. Look at this. The 2 kg block, we have the tensional force going up, and we're going to have my Fg going down. So the free body diagram for 2.2, it will be tension up and Fg. Then you're going to collect the 2 marks for just writing it like that. Let's work on 2.3. So look at this. On 2.3, they want us to calculate the frictional force needed to keep the blocks at rest. So now I need to explain something. Let's try to draw, or let's indicate all the forces that are acting on the block. As you can see, I have the tensional force going up, and there's another force that always acts down, which is Fg parallel, the weight, the parallel weight. So now remember, there is a friction that is keeping this 10 kg block from sliding down. Look at this, the mass of this is 2, the mass of that is 10. So you can see that if we cut the rope, the 10 kg block will slide down. So the friction that is blocking the block from going down, it will look in the opposite direction. So we're going to call that F, and it's going up. So when we draw the free body diagram, we are saying that the frictional force is going up, and we have the tensional force in the same direction as the frictional force, and we have the Fg parallel pointing down. So now remember, these blocks are at rest, which gives us the F net to be equals to 0. The acceleration is 0, the object is not moving. Okay, so now let's choose direction. I'm going to take up as positive. So we need to find the frictional force needed to keep the block at rest. So up as positive tells me that I'm going to take my tensional force, add that with the frictional force, then subtract all the forces that are going down, equate this to 0. So we need to first calculate tension, and I think everyone can see that it will be easy to use the 2 kg block to calculate tension. This is my tension, and this is my Fg. So we already have up as positive. So we are moving up in that direction, it's positive. Then look at this. So we are forced to take down as positive. So if we take down as positive, we're going to say F net is equal to 0. We take all the forces that are going down, we subtract all the forces that are going up. This is 0. So my Fg is equal to T. So the tensional force is just mg, because the weight is mass times the gravitational force. So I'm just going to substitute this. The mass is 2. Remember, this is for the 2 kg block. So this will be the mass of 2 multiplied by 9.8. We add F, we subtract. What is Fg parallel? Fg parallel is equals to mg, the sine of theta. So we need to say the mass. Remember now, this one is for the 10 kg block. So the mass is 10 into 9.8, and the sine of 30 degrees, this is equal to 0. So once you isolate this and solve for x, the answer of that frictional force is the force that is needed to keep the block at rest. So now this is okay, let's fix something here. Remember, we are forced to okay, let's fix something here. We're going to say this is 19.6. When I say let's fix something, we just punch this on the calculator. and we punch that on the calculator. So this will be 19.6 plus F, then we're going to subtract. When we punch that on the calculator, we get 49 newtons. So it's 49 is equals to 0. So now I'll move the F to the other side to be negative F. It's equals to 19.6 we minus 49. So let me quickly put that on my calculator. 19.6 minus 49, that's negative 29.4. So this is negative 29.4. Divide both sides by negative. What is frictional force? Frictional force is positive 29.4. Since it's positive, this tells you that the frictional force is going up the slope. It's going up the slope. So the answer for this is going to be, we're going to say the answer is frictional force is 29.4 up the slope. And ladies and gents, once you have all these steps, you're definitely going to collect that 5 marks. So now there's something that we need to go back and fix. Remember, there's a formula for this part. So please don't start writing F net is equal to 0, but write F net it's equals to MA, because there's a mark for that. Then that's when you can say F net is equals to 0. So there's a mark for that, and you're going to get a mark for calculating the frictional force. There's a mark. So far you have 2 marks. So you're also going to get a mark for calculating your FG parallel. That's another mark. So far you have 3 marks. So when you have it like that, they will give you a mark for equating this to 0. For saying 0, this is a mark. Then so far you have 4 marks. The final mark is for frictional force. And that's it for this lesson. Thank you very much for watching the lesson.